the 2 to the power of n minus 1 plus 3 to the power of 2n plus 1 is a multiple of 7, or we can put that in this manner, that in multiple of 7 just means 7m, where your m belongs to z. So let's start our proof. Put n is equal to 1, so what does LHS becomes? 2 to the power of 1 minus 1 plus 3 to the power of 2 times 1 plus 1. So that's just 2 to the power of 0, 3 to the power of 3. So that's basically 28, right? 2 to the power of 0 is 1 and 3 to the power of 3 is 27. So hence it is 7 times 4. So this is equal to your RHS, where your M is equal to 4, right? So N is equal to 1 wholes. So this is your step 1. Let's proceed towards step 2. Assume n is equal to k is true. So what do you get by this assumption? You get 2 to the power of k minus 1 plus 3 to the power of 2k plus 1 is equal to some 7 times alpha. Let's label it as the first. Now we will be using step 2 to prove step 3. Step 3 to prove n is equal to k plus 1 is true. So what do you get from here? 2 to the power of k plus 3 to the power of 2k plus 3 is equal to some 7 alpha dash. We need to prove this. So from the first, let's just rearrange this. So what do you get? 3 to the power of 2k plus 1 is 7 alpha minus 2k minus 1. So we're gonna sub in over here on LHS. So let's see how. LHS becomes 2 to the power of k plus 3 to the power of 2k plus 3. Now let's just break this part where the 3 is there. So what it becomes? 2 to the power of k, 3 to the power of 2k plus 1 plus 2. Okay, that becomes 2 to the power of k, 3 to the power of 2k plus 1 and 3 to the power of 2. Right? Now 2 to the power of k, 3 to the power of 2k plus 1, 9. So let's just from first, what do you get? This becomes 2 to the power of k, 7 alpha minus 2 to the power of k minus 1 times 9, right? So 2 to the power of k is there, and here it's k minus 1. Let's make the power same. So I'll pull 1 2 out. So it will be 2 to the power of k minus 1, 9 times 7 alpha. I'm multiplying this 9 with the given bracket. So it's 9 times 7 alpha minus 9 times 2 to the power of k minus 1. Let's just consider these two terms in the separate column over here. 2 to the power of 2k minus 1 minus 9 to the power of 2k minus 1. Let your x be 2 to the power of k minus 1. So it becomes 2x minus 9x. That's basically negative 7. If I sub in the value of x, I get 7 times 2 to the power of k minus 1. That becomes 9 times 7 alpha, negative 7 times 2 to the power of k. If I pull out a 7, I get 9 alpha minus 2 to the power of k. Right? So what we require an alpha dash. So can I say, let alpha dash, it's 9 alpha minus 2 to the power of k. So this is equal to 7 alpha dash, and hence a multiple of 7. So this is equal to your RHS. So we can say this gives us n is equal to k plus 1 is true. Therefore, by mathematical induction, given statement is true for, let's see, for all positive integers n. So here, that is the proof